You're walking on the street on a rainy day. Drops of rain started to drop on your shoulder. Meanwhile, you're wondering. When rain drops on our body, you can feel the weight of rain hitting you. However, when light shines on you, why can't you feel the weight of light just like that of the raindrops? People think that light is a wave, as people can't feel heavier when light shone on them. You also can't measure a weight for light with a balance. Wave consists of two parts. Imagine you are in the wild mountains. The mountain consists of a peak and a valley. The waves are just like a mountain. Eventually, you get back home. You turn on the lights in your room, sit on the chair, and started working on your homework. The homework is so difficult that you can't focus on it. So you looked at the wall and suddenly got a bizarre question. You thought, Wi-Fi can pass through walls and come to your phone. That's because Wi-Fi is a wave and can pass through walls. Assume there's two dark rooms which are just separated by a wall. If you open the lights in the first room, the second room will remain dark. Light cannot pass through the wall, so it may cause you to think that light is a particle instead of waves. Some scientists think that light is made up of particles. They used photons to try to prove that light is made up of particles. Photons are the basic component of light. Numerous photons make up a beam of light. It's just like students making up a class. When photons hit an object such as a metal plate, electrically charged particles called electrons will be knocked off by the photons. This is called the photoelectric effect, in which only particles have this property. And scientists have proved that photons or light have this property. So light is proved to be made up of particles. On the other hand, other scientists think that light is made up of waves, and they try to prove that by showing that light undergoes interference. But what is interference? Imagine the water waves in the sea are high and low. When the higher parts of the two waves crash together, they will add up their height together and become higher. On the other hand, when a water wave in the high part crashes into another water wave's low part, they will cancel out each other, and it will just become flat. This is called interference, which only waves have this property. Scientists prove that light undergoes interference, and hence they are waves. How strange! Light is proved to be made up of particles and made up of waves at the same time? So it's light made up of both particles and waves? Or is it made up of neither of them? It became one of the largest crises in physics. But don't worry, we will guide you through the history and show you how it all happened.
Wave scientists designed an experiment which shows light undergoes interference and deduced that light is made up of waves. The experiment is called the Young's double-slit experiment. They know that if a wave passes through a double slit, two new waves will come out from the two slits interfere with each other. Hence, it will leave this interference pattern. If a particle passes through a double slit, it will leave this pattern. Because particles can't pass through an object, it will be blocked, such that a body can't go through a wall as you are made of particles. Scientists who believed that light is made up of particles thought that the previous experiment wasn't legitimate. They claimed that it's the photons colliding with each other to cause this kind of interference pattern. So, they decide to redo the experiment, but they shoot out a photon at a time. Scientists expected that no interference pattern would be formed on the screen, as photons cannot be affected when there are no other photons next to it. However, interference pattern appeared unexpectedly. It seems that particle size scientists have lost. The wave size scientists said that the photons split into two and interfere with themselves. Light is proven to be made up of waves at that time. However, the particle size scientists didn't give up. They finally took out their ace in the hole, an observer. The observer can find out if the photon passes through the two slits at the same time by slitting itself into two. The device is placed in front of the double slit in order to observe the photon. Strangely, when the observer is on, the interference pattern disappears, and instead the no interference pattern appears. This makes both sides of scientists unable to prove whether light is made up of waves or particles. So, what is the truth? It seems like simply observing the photons will change their behavior. This is one of the misconceptions people have about this phenomenon. An observer is not anything like the human eye or camera. It's an electronic detector which can obtain the photon's location. Actually, the electronic detector must interact with the photon and change the photon's behavior in order to obtain the photon's location. It's just like checking the pressure in a tire. Some air must escape while doing this and change the pressure. Hence, the result is affected. So, how exactly did the observer change the photon? The phenomenon can be explained with a wave function. What's a wave function? Wave functions are like the ID card of the photons. It contains the information of the photon, including its position and its velocity. But in the quantum world, we cannot know exactly the position and velocity of the particle. The wave function only shows the probability of where the particle is and how fast it is. Imagine the wave function as a platform in the air, and the photon is standing on it. There's three parts of the platform: left, middle, and right. Assume the photon is standing in the middle part. When the device is observing the middle part and knows that the photon is standing on it, the device destroys the left and right part. So it's impossible for the photon to be standing on the other two parts. In real life, it means that the wave function collapses. Back to the experiment, we know that the electronic detector will affect the behavior of the photons. It affects the photon's behavior because it has located its position. When the detector locates its position, its wave function collapses. The size of the wave is greatly reduced and could only pass through one of the slits. Hence, it shows the particle property of light. So, at the end, these experiments can show both the particle property and the wave property of light. And finally, we said that light has wave-particle duality. Not only small things like photons and electrons have wave-particle duality. Actually, all substances in the universe are formed by wave and particles. Although the behavior of relatively large objects are dominated by their particle nature, which means that the particle nature of large objects are much stronger and more obvious than that of small substances. Through the Young's double-slit experiments, we can conclude that light has both wave and particle properties. That means light has wave-particle duality.